Hello everybody, welcome to this new Pix4D webinar. Today's topic is Pix4Dmapper Overview, and my name is Oliver Kung, and I'm very happy to present this webinar again. So let's directly go into the agenda to understand better what we're going to talk about. Today's webinar is really going to be about a high-level understanding of the software, or what are all the capacities of the software. So we are going to go through many a demonstration of most of the features of the software without detailing too much the real steps one by one on how we're going to, on how you can achieve of like inserting GCP and so on. However, I'll give many pointers to our other webinars and very extensive knowledge-based content. So together with the YouTube version of this video, there will be many links provided that will give a lot of pointers on more specific subjects if you need to know how they to really go step by step for all the features that I'm going to demonstrate today. Being that said, here are the most important parts we're going to cover in the software today. The first one is going to be Pix4Dmapper processing, how to really use Pix4Dmapper just by giving data and checking the outputs. Then I'm going to talk a little bit more about all the different possibilities that exist before processing on how to correctly input your project into Pix4Dmapper. Then I'll discuss about another subject which is always extremely important, is how to assess accuracy. What are the features in the software that allows you to assess the accuracy of your projects? For this one, I'll mostly use the tool that is inside of Pix4Dmapper, which is called the rayCloud, and not only to assess, but also how to control the data. Then we'll talk about a few additional features that allow you to measure points, surfaces, volumes, how to remove points, and how to classify the points, and how to animate, to produce video animation to make nice videos of your results. I'll also mention the mosaic editor tool that we have, as well as the index calculator. What are the possibilities to upload projects to Pix4D Cloud, and all the additional outputs that are also features of Pix4Dmapper. You can ask questions in the small chat box if you are watching this webinar live, in the small chat box of the GoToWebinar screen, and I will be catching up the most relevant questions during the webinar and answer them on the fly. Otherwise, there's also the support team that's able to answer you live for more specific questions. So let's directly start with some practice. And we start by creating a new project. So the easiest way of using Pix4Dmapper is by really creating a new project. For that, you need to specify the name of a project. Test project, for instance. The directory, this is the directory where most of the files will be generated. So make sure that this directory contains enough hard disk space. Simply click Next. Up. If you have imagery, then you simply take your imagery, drag and drop it into the project. Click Next. If everything is fine and your image is already geotagged, then you have nothing else to do. You click Next. Your project is finished. You'll have a satellite view with the project. You'll have this window on the bottom, which is called local processing, that can be activated by clicking on this button over there if it gets lost. And then you simply press on Start Processing. you will see that the progress bar starts to fill up, and it will go through many cycles. So it's not at the first finish, it doesn't mean the processing is finished. It just means that it has gone through one of the multiple steps of processing. At that point, you don't need to save or to do anything or to have many manual interaction. The software is just going to automatically do all the processing for you, generate some default outputs, and save them on disk. As a trick for people that don't have any data to start with, we have included in Pix4Dmapper, so I just quitted the processing and start the software again. We have included in the software a tab called Guided Tour. If you click on this guided tour, you are greeted with this big button there. And if you click on it, the software is going to load a project that comes together with the installation of Pix4Dmapper. In addition, it's going to ask you if you want to see a guided tour video in the browser. If you click Open, you will have a YouTube video that will guide you through most of the features of the software, a bit like the webinar of today, but with much less detail and only in 15 minutes. This guided tour has already a project created for you, so the only thing you need to do is click on Start to start the processing. To save a bit time, I've already clicked Start on another instance of Pix4Dmapper, and as you can see, the values here are not red anymore but green, which means that it has already been processed. So now it's time to access to the results that have been computed using this simple, after clicking simply the Start button. When you created the project, as I mentioned just before, there is a directory that you mentioned where most of the files are going to be generated in. So you don't have to click on Save anything, the files will be generated in that directory. When you are in the map view, you will see on the right that there is a mention of that directory where the project has been processed. There is also a very useful icon on the top in the menu bar, which is called Open Result Folder. If you click on it, it will automatically open a Windows File Explorer at the right location. So let's quickly explore the different folders of the basic results of what you get after clicking Start. If you click in the first folder, you will get the initial results. By default, the one which is the most interesting for you is the report. The report can also be accessed by clicking in the software the Quality Report button there. This is a document that I'm going to talk later on how to analyze it, but that gives you a lot of details on how to assess the quality of the processing. So this is the most important things you have to check in the folder is this report, and there will be a PDF file at that place. Then the second folder called densification. In this one, you will have the point clouds, data which is very similar to what you would obtain with a laser scanner. In the first directory, you have the point cloud in multiple formats, depending on the option you choose, that can be opened with any laser scanning 3D points software. In the second folder, you'll have a filtered point cloud, which is very similar to this point cloud. However, it has much less points. It has been filtered out from some noise, and also to make it smaller such that it's easier to read it in third-party software. A demonstration of this file would potentially be, so that would be any generic point cloud viewer. You would take one of the files that has been generated, and you can visualize the point cloud results. In the third folder that will be automatically generated if you don't change any option, you will have two main folders. The first one is a DSM. The DSM is a file that contains, for each pixel, which will contain an altitude. You cannot open it in the Windows Photo Viewer because Windows cannot interpret altitude, it can only display color. So for displaying this file, we recommend using GIS software such as Global Mapper or Quantum GIS. If I use Global Mapper, for instance, to open this file, you can simply drag and drop it, and here you will see for each pixel the altitude of this file. There's another folder called Mosaic. This one is really the orthomosaic generated by the software. So this one can be double-clicked and opened in any GIS software, but also in Windows Photo Viewer, and you will see all the images assembled together in such a way that you can measure accurately in it. All these files I just mentioned are all georeferenced because they are contained in the metadata of these files. There is the information about which is the coordinate system and at which area they are placed. For some more old software where you need to input these files in, they are not always able to read the metadata inside of this imagery. So that's why we also generate this .prg and tfw files, which are simple text files that you can open with a notepad, for instance. And these files contain simple information about which projection system was used and what is the location on the world using this projection system. As you could see in this example, there are many other outputs that were generated, but this one are not generated by default. And I'm going to talk more at the end of the presentation when this additional output occurs. For now, this is what I just explained there is really the most easiest way of using Pix4Dmapper. You put data in, you click on process, and it generates some outputs that you can use then further on in your traditional workflow. All the files that I just mentioned are extremely standard and can be opened in any GIS software or laser scanner software. So you may, for people that are already using such tools, then it's just files that can be used in the traditional workflow. We have many webinars and also articles in the knowledge base which are detailing exactly in detail what are the properties of these files and in which third-party software like AutoCAD, ArcGIS can they be opened and how to do so. However, your data may not be always perfectly fitting to, you cannot directly import it. You need to specify a bit additional information about it. And that's what I'm going to talk about right now. So before processing, what are the options and which are the features you should be aware of before clicking on this Start button? Maybe I will just, before that, answer a few questions in the question box. One would be, as a question somebody asked, would Revit be a compatible third-party software? Yes, definitely. You could import the point cloud there. Then there are two questions about georeferencement, and this is exactly what I'm going to talk about right now. And when you create a project, I went very quickly over a window that was talking about the geotagging, the georeferencement. You can do it during the wizard that creates the project, or you can also click here on the image properties editor after you have created the project. So it's exactly the same window. In this window, you have three main categories. The first one is the image coordinate system. This is if in case you have geotags. This is where you have to tell the software in which coordinate system are your geotags. If you've been using a GPS device together with the images, likely you want to keep the VGS84 coordinate system, because this is the most common for most of the GPS devices. And so you don't have to do anything. However, from some other specific needs, you may want to change that to something else. If you don't have any geotag, then basically you have nothing to do in this page, and the software will still process your imagery. This is really to specify the geotag of the images. So the first box is really about defining the coordinate system. The second box is about specifying to know how many of the files that you have a geotag assigned to them. By default, the software is going to try to read it from the metadata, from the EXIF information of the images. However, there's also a possibility to import it from a text file. We support many different formats, and you have to really make sure that you choose the correct format before importing. This is a cause of many error when people are importing images into the software, when you are not processing the correct flight log or the correct format. If you click Help, you will be redirected to a much more detailed information about which is the exact format in which this file has to be correctly processed by Pix4D. So if the software correctly imported the geotag, you will see here coordinates appearing. So in that case, it was in latitude, longitude, altitude, and you have the information there. A very good way to know if the geotags were correctly imported is to go into the map view, and the map view will display as a red box, as a red circle dot, the location of the images. So by zooming out, you can quickly view that indeed this project is well placed in Switzerland, where it has been acquired. So let's go back to the image property editor. The last box is about the select camera model. So the software is using the properties of the geometry of the camera, of the physical camera device, to be able to recompute the 3D information and to find the position of the images. To do that, it's using many parameters that are inside of the camera, and one of them is, for example, the focal length. However, in addition of having this information, the software will recompute and re-estimate at every single project what is the exact focal length that was used during this flight. And what is reported by your camera is not always the same that's what's inside of the camera. For many reasons, such as temperature changes because of vibration, because of shocks, because of just natural changes with time, the focal length will change with almost every project that you are processing. And the software has to estimate this value. The good news is that it's doing everything for you, so basically you have almost nothing to do there. However, to be able to perform properly this optimization, the software has to start from an initial parameter. And if the initial parameter is not too far away from the real solution, it's going to process very nicely. However, if the initial focal length, let's say that for a camera that has a 18 millimeter focal length, if you input as an initial guess 3 meters, the software will very likely end up in a failed processing because the focal length estimate that was given at the beginning is really way too much different. Pix4Dmapper has a database of known camera. So we have a very large list of camera that we've already processed and for which we have already a very good initial guess of the focal length. If this is the case, you will see a little icon there which is database, which looks like a database. If you have a project which from a camera that is not in our camera database, no panic. The software by default will try to guess a reasonable estimate of the focal length and will put it there. However, for best processing, make sure that if you have a camera that which is not in our camera database, that you click on Edit, that you look on the specification sheet of your camera, and you try to fill in the value of the sensor width, sensor height, and focal length. These are the most important values to put there. This will ensure that you'll have a much better chance of processing your data in the first tries. In addition, if your camera is not a normal color camera, but is a camera more designed for agriculture, which would be, for example, an infrared camera, make sure that you choose the correct bands there. For example, red edge, green, blue, and you select the right one for this project. This has a very big influence on the quality of the processing. So for specific cameras, make sure that this is correct. By default, the software will try to recognize automatically this data. So for most of datasets, you will have nothing to do. One last thing I'd like to mention in this window, which is very important, is these two columns called accuracy, vertical and horizontal. These values try to give an estimate on how much do we trust the initial accuracy of the project, of the geotags that we just inputted there. Most commercial GPS have not a great accuracy. More in the range of 5 to 10 meters. In addition, the accuracy is not only about the GPS, but about how well did you synchronize the GPS together with the camera. So in that sense, it makes a lot of sense to have quite a large value there. And for most of the projects, we recommend to keep the 5 to 10 meters accuracy. If you have a specific UAV type, let's say DJI Phantom Vision. The DJI Phantom Vision has a very low accuracy when it's doing geotags. In that case, we would rather advise to set the settings not to 5 and 10, but most likely to 50 and 100. And just as a quick tip, if you need to change multiple values rapidly, we would recommend to use the Shift key to multi-select multi-columns, and then right-click with the mouse, click on the button, and now as you are editing one value, you can see that it's editing all the other values in the column. So this is a quick way to do multiple group selection. Okay, this is one of the things to make sure that is correctly set before doing the processing. Another important toolbox is the GCP and manual type point manager. This is where you will want to import a file that contains additional information in the terrain of some other points that you have measured there. So I'm not going to go into the whole discussion what is a GCP and what is it used for. For that I will really recommend to check the previous webinar which is dedicated to that topic. But just to have a quick idea, as your UAV will have very likely a commercial GPS on board, the geolocation might be not that accurate and you'll be a few meters off. So how to make it the whole geolocation more accurate is by adding points that you have measured on the ground with a more accurate device. You measure these points, and then this interface that we see there is the interface to import these points inside of the software. As the geotags, you will first have to select the correct coordinate system in which this GCP have been measured. So here you have the whole toolbox on how to select the coordinate system. And then you import a file, which is again a CSV file in which the format is available if you click on the help button. If everything has been correctly imported, this is what you would see on the map view. As I mentioned before, the GPS is the red dot, and the blue crosses are the ground control points. If you don't see the ground control points when you imported your project, it's very likely that either you did a mistake when selecting the coordinate system, or that you didn't import the GCP file in the correct form using the correct format. So I really recommend to check these two things first. Finally, there's also the possibility to select the output coordinate system. This is in case where you want the output to be in exactly a specific format, coordinate system. By default, if you have only GPS information as geotag, the output is going to be in UTM. However, here you can override that settings to have it in any other coordinate system. If you import ground control points, then the output coordinate system by default is going to be in the same GCP coordinate system. And if you don't have any geotag, then the coordinate system is going to be in this arbitrary coordinate system instead of being in a known coordinate system. The last thing that is potentially possible to do before doing the processing is to add this polygon there. This polygon, actually there are two of them. One is the point cloud densification area, and the other is the orthomosaic area. What this polygon does is that it tells the software that during the processing it should restrict the area where it computes points only to this polygon, and the same for the orthomosaic. Why do you want to do that? For two reasons. For speed, as you restrict the area where you have to compute data, it's going to be much faster to process. And secondly, because very often the borders of the mosaic, because there's less overlap, will be of lower quality. So this way you can also have, you increase the quality of the visual output by not taking the borders of the orthomosaic. To draw such a point cloud densification area, you right-click on this window and you click Draw. You'll have then a drawing tool that allows you to define this area. And then you'll have also to do it for the orthomosaic area. Once all this is perfectly optional, but this is one way to prepare the data before processing. So let me check the questions which are now asked by several users. So a user asks if the geotags can be imported from EXIF collection. So as I mentioned in the dialog before, yes, it can be. The software is automatically going to read the geotag inside of the EXIF. Can you create one? Okay, so the here we show the boundaries as a pre-processing step, but it's also possible to define these boundaries as a post-processing step once you have the final orthomosaic. So, which I'm going to show later on how to do that. Okay, so now let's move to the subject, which is about accuracy. How to assess accuracy? Which are the features in the software that allows to assess the accuracy? And something which I would repeat over and over is it's not because the results look pretty that they are accurate. And that's something very, very to be aware with this software, because most of the time when you put images and this aerial images from UAV, the results will look extremely pretty. But it's not because it's pretty that it's accurate, and there's a big difference into that. I'll give you two examples. The first one is locally you could generate a project, everything could go well, you would see everything seems reasonable. However, the elevation model for some reason was not perfectly flat, but was slightly tilted. It will be very difficult if you just look at the results in a GIS software to see that there was a tilt in this elevation map. And if you use then this elevation map to, for example, build a house and so on, you may end up with a tilted house, which is probably something you really don't want to have. So it's extremely hard to know if, even if the whole elevation looked reasonable, that you could see details and so on, it's very difficult to assess if it's, for example, slightly tilted or slightly bended, which have big consequences when you then use it to do real work behind that. The other example I'd like to discuss also is, let's imagine we fly at night, at midnight, when there is no sun, no moon, no lights, no flashes. Obviously, the images will be extremely dark or even totally dark, and you can already expect that the results will be either failing or extremely low accuracy. So that was the extreme example. Of course, if you do it at noon with lots of sun, things will go well. But then what is the limit? When can you start trusting the data because the images were high quality, and when should you not trust the data anymore and things may be of low quality? For example, if the images were extremely dark, very noisy, and with very little details in that. So these are just two examples to really push the point that pretty results is not enough. And it's very, very often that you have pretty results which may not be accurate. And now I'm going to discuss on which are the tools that would allow you to assess a little bit more what is the accuracy. The first of this tool is something I already showed before. It's this quality report. To access the quality report, either you can click on the icon which is in the menu bar here, or you can open the result folder and go in the first directory and then in the report subdirectory. I'm not going to discuss in details all the ways to assess the quality in the quality report. There's other knowledge-based articles and also as well webinars dedicated to this issue. But I'm just going to give you a quick overview of what's really, really important. The first thing to really check is these 5 green checkboxes. If they are all green, it gives you a high confidence that things went pretty well. It doesn't mean still that everything's perfect. For that, I'll show you a few more tools that would be also good to assess the accuracy. But it gives you already a high confidence that everything went correctly. And if this green box can start turning yellow, in which case it's more an indication that it may be very accurate, but we would still recommend you to do additional checks to make sure that it is really accurate. And then they can also turn red, in which we really detected that there are obvious mistakes that, that will probably damage a lot the quality of the results. If this happens, that these boxes turn yellow or red, then the best thing to do is to click on this small question mark here on the side. Example, if this checkbox would turn orange, then you would click on this box, and it will redirect you to the detailed explanation in our knowledge base about what happened, what is probably the issue, and how can you improve, what can you do to improve to make sure that you can still get quality results out of that. So this would be the first way to assess the accuracy of your results. The second way to assess the quality of your results would be to click on the rayCloud editor right there. The rayCloud editor, I'm going to discuss a bit more about it in more details just there, but just as a basic functionality, one way to check the quality of the results is clicking randomly in the project, let's say here, and on the right you will see different images with a little green cross. If this green cross is reprojecting on the same feature of your images in all the different images, this gives you a high confidence that the whole project is pretty accurate. And one good thing to do is to check it at several places in your project, sample more where your project is really important, and by looking that, it can give you a real quite confidence about the quality of the project. As a rule of thumb, the green cross should be within 10 pixels of between each of the images. So it can be not exactly on the same pixel, it can be just a little bit around. But if it starts to be really at a much larger distance, then that's where you need to really worry and start reading more items in the knowledge base about how to fix that. Finally, one of the most popular way and one of the best way to really assess the accuracy is by introducing ground control points and checkpoints. And this is related to the box I was just mentioning earlier. I'm not going to go all the details about the ground control points and checkpoints and how to assess accuracy about them, as there's a whole dedicated webinar about this that I would really recommend to watch. So now I'm going to explain a little bit more the rayCloud, how it works, how to navigate in this interface, and what are the additional features, things you can do with it. First, this rayCloud is much more than just a simple visualizer or even editor. The reason we call it rayCloud is because every time you click on a point, it has the whole interaction between the 3D model that has been computed, and with these rays that you can see here, you have the link to the original images that were used to generate this model. And there you really have the perfect interaction between the images, the original images content, and the 3D model that has been computed from these images. So maybe the first thing to explain is how to navigate in this rayCloud. So the controls are very similar to the controls used in Google Earth. With the right click, with the left click of the mouse, you pan as if you were grabbing the map. And you can take the map and go at the location where you are. Using the scroll wheel, you can zoom in and out in the point cloud. To rotate, you can use either the the middle button of the mouse, or you can right click and left click together and then rotate, or you can use the shift key of your keyboard and then press the left key of your mouse to rotate. There are also many possibilities to change the view on the rayCloud to go directly in the top view, in the right view. There are some shortcuts with the keyboard on how to move faster between them. There's also possibility to view the whole project or to focus on selection to have a closer view of something. As I move the mouse, you can see in the right bottom of the screen that the values are changing. This is where you can get the instant coordinates of any point of the rayCloud. You can also click individually on the camera. When you click on a camera, you will see here on the right the original image overlaid with orange crosses. Each of these crosses are the tie points which are used to calibrate the images. For more details about all this interaction, I would advise to check the rayCloud webinar, which goes much more in details about all the different options on how to display the values there. When you click in the rayCloud, there are 3 types of points that you can usually click on. So on the left panel, you can see that you can unselect for displaying whatever you want to display. So here I unselected everything. So let's put back the cameras and let's display then the automatic tie points. If you click on an automatic tie point, you will have many values on the top which gives you an assessment on how accurate and how well this tie point was computed in how many images, as well as the position of these tie points. If you right-click on this box, you can copy it to the Windows copy-paste. So you can copy it, open an Excel sheet, and paste it to get this value in an easy format to reuse them later on. If you click on you can load here point cloud, dense point cloud. If you click on a dense point cloud, you will have less information about the points, but you still have the reprojection in every single images. And if you click on manual, so let's display now the manual tie points. If you click on the manual tie points, you will have the same box, but now with additional, you will see what was the coordinates that you used to generate, to give in addition to this tie point. This is also where you can, this is a shortcut where you can change the type of the tie points to being a ground control point or a checkpoint. Again, for more details on all the different features, it's a whole webinar to watch, which is about the ground control points. So let's go back into displaying the point cloud. I just mentioned earlier what are the tools to assess the accuracy, right? So it's the quality report, checking what I'm doing right now by clicking on a few points to check here the accuracy, if everything reprojects correctly, and also the ground control point. However, this is just to assess. Now, if I want to control, if I want to have some control over it and to do some changes, well, one of the way that the software one of the feature that the software can really help you with is, let's pretend you click on a point and you see that the green cross is not exactly aligned on the right feature. Well, in that case it is, because the calibration went very well, but if it weren't, if it was not, then that's where you can use the new type points feature. In this box, when you click new type points, it will allow you to generate one of these type points that were used for the calibration, but this one will be taken much more in consideration, and it will very likely help the software to better align the images in that area. For that, you will need to, as I mentioned, click on this Add New Type Points, and then you have to click in at least 2 images the exact same location of these type points. Let's try to click top of this tower. 2 clicks is usually not enough. It's enough to give, so as you can see, here's the cross that has been computed by my 2 clicks. It's usually enough to give a first estimate, but using multiple clicks from multiple view angle will allow you to improve a lot the accuracy of the definition of these points in 3D space. So, for instance, here I can see that the point was not exactly set at the right place, and by refining and clicking more, I can adjust it. One very useful option to check visually how clicking more really improves the calibration of these points, the definition of these points, is to go in Type Point on the left panel, Display Properties, and then to click on Show Error Ellipsoid. Here we visualize how much error potentially there could be on this type point. It's not really the correct scale, so it's not the error here is not an error of 100 meter, but it gives you a good assessment that this point that I just clicked here is not defined as well as the point which was clicked previously in another session just there. So it really gives me an indication that when I did my clicking, either I haven't selected enough images or I haven't done correctly the selection. So by adding more click, I can reduce this error. And every time I click apply, you can visualize now that this error has changed a lot. And the more pictures I am adding from different view angles, the more I can refine even more the accuracy of this measurement to have it to something which is more reasonable and more aligned with respect to the other ones. Once you have added a few manual type points, you still need to reprocess to have the software taking them in consideration when realigning the cameras. This is the reason where you could really start the processing from scratch, but it's a bit wasted time because you've already done most of the processing. So that's why you have these 2 additional buttons there in the menu bar, right next to the local processing. The first one is called Reoptimize. By reoptimization, the software is just going to take the additional information that you've added with the manual type points on possibly the ground control points, and it's going to quickly perform a new alignment taking this data in consideration. If you are in a situation where the data was really, where some images were really not at the right location for some reason, that they were really bad, but then you added some manual type points, if the calibration was really poorly performing, then reoptimizing will not be enough. In that case, you will want to hit the rematch and optimize, which will take more time than simply optimize, but which will be able to even realign extremely badly calibrated images. Then I have a question about the accuracy of most what I've been talking about, since we are still in the assessing the accuracy. Most of the time, so we have a whole, again, webinar dedicated on accuracy, but as a rule of thumb, you can expect to have 3 pixels of accuracy in vertical, and about 2 pixels in vertical. And this is with or without ground control points. Now, if you have these 3 pixels don't have a dimension, so I cannot tell you that's going to be 15 centimeter. However, if you have ground control points, then the ground control points of a high enough quality, then the geolocation will be perfect, and then the accuracy of your project will be really 3 pixels, meaning 3, if your ground sampling distance was 5 centimeters, it will be the standard deviation of your accuracy is very likely to be better than 3 pixels, meaning 15 centimeters. Okay, now quickly going over the additional features of the software, which are less about accuracy and how to control the accuracy, but much more about what you can do to further explore and use the software. So one of these possibilities is doing measurements. We have here the 3 buttons that allows you to do simple line measurements, surface measurements, and volume measurements. So let's take, for example, we need to measure the what could we measure here? Okay, this looks like a truck. I want to measure the size of the roof of the truck. So I will select create new polyline object, select 2 points in the rayCloud editor. To finish creating my line, so the first point I use the left click, and the last point I will use the right click of the mouse. There I just defined a line. Here on the top you will see that the error was measured being 1.7 meter in this project. It's always very hard to assess if I clicked the right points in the point cloud to make sure that this was really the points I wanted to click. And here in the rayCloud editor you can see the reprojection of this measurement. One possibility that you can do is you can refine the measurements by adjusting the points in the images. If you do this refinement in at least 2 images, then you can be much more precise in the way that you measured the object. And by clicking on enough imagery, you are able to see also the same error ellipses, which are getting smaller and smaller, telling you that indeed you are being more accurate while you are doing the measurements. In that case, so before it was 170 meter, now it's 140, because I was able to really click on the perfect part of the roof of that truck that I was interested in. So exactly in a similar fashion, you can also compute surfaces by selecting the surface tool, and you will get the surface in 2D measured there. And then if you're interested in measuring a volume, then you would choose the stockpile object there, click around your stockpile, and there you can see that the stockpile is underlined in red, and you have all the measurement values there. As usual, if you right-click on these measurements, it will copy them in the Windows copy folder, copy system, and then you can paste it into any Excel sheet. All these measurements that I just performed, so you can either export the raw measurements there, but you can also export each of the objects that you created, the lines individually, either in DXF, shapefile, KML, or DGN formats. So most of the formats that can be read by any third-party processing software, GIS or CAD software. Now for a little more advanced usage, let's see if I wanted to measure the volume of this specific stockpile. However, what you can see in this stockpile is that there's a truck on it, and I don't want to measure the volume of the truck. So if I would do a simple volume measurement here, it will measure the stockpile and the truck. So what should I do? The best thing to do is you can select now this option there, which is the Edit Densified Point Cloud. If I click on this option, I'm now in the editing point cloud mode. What can I do with that? I can go over this stockpile, and I can click here on the selection box. By pressing the key, the mouse, I can select parts of the point cloud. This will put them in the red color. If I did some mistakes, I can go back by clearing the selection and redo my, my selection. By unclicking this, this box, I can move around to see if I correctly selected these points. Okay, so once these points are selected, you can click either on the delete key or pressing on this button. This just removes these points. You can now exit the point editing tool. At that point, the software will ask you a question. It will ask you if you want to refilter the point cloud. And this is necessary because the volume measurements are performed on the filtered point cloud and not on the point cloud that you just see there. So you need to press OK. And this will take a few seconds to reprocess. So I'm not going to do it there. Once this is done, you can re-click on the volume generation on the stockpile object, click around the stockpile, and then the measurements that you will obtain are the measurements which are obtained without the truck on top of it. So you can really measure the real volume and not the volume of the truck and of the stockpile. So this way, I showed also the editing tool. This editing tool is not only useful for volume calculation, but it's also useful to clean up the point cloud, as the point cloud is going to use to generate the orthomosaic. So for instance, if in the orthomosaic you can see that there's a little bit of noise, so let's run the orthomosaic to see what I'm talking about. So in this orthomosaic, let's try to see a sharp edge. In this very little place, you can see that there's a little bit of noise when generating this orthomosaic. The reason is because the point cloud was very likely to be a little bit noisy in this area. So one thing you can do is go in this area. Okay, so indeed the point cloud was a little bit noisy because the image was saturated. So you would go in this area and you could use the point cloud editing tool, delete the points which are in this area, and restart the generation of the orthomosaic and the elevation model. And these points will not be used and will not create these artifacts anymore. Another way to improve this, to use these points and to improve that, is by selecting the surface area and by drawing a surface there. This will also improve the orthomosaic and the elevation model as it will really make sure that the points which are within this surface will be all removed and make sure that there is a flat surface at this area. So this can really improve when you have a little bit of noise on some edges. There you can have manual controls to improve it. Finally, the last tool I'd like to show in the Mosaic editor is the one to create animation video. So this is this little icon on top there. By clicking on it, you will be greeted with a small wizard that lets you choose between the user recorded view or the computed camera positions. Most of the time you will want to use the user recorded view. Press next, and then you are within the view, and you can move around to select where do you want the video to start. So let's pretend you want to start the video with this view. You will record your first point. You will move a bit further away, record another point. Let's go there. Press next. The duration by default is set at 10 seconds, but you can change it now or later on. Press finish. And here you can visualize what is the path that the camera will do during this animation. To select the animation, you just go on animation trajectory and select the right animation, and then click on play. And this gives you a preview on how the video is going to look like. If you're not happy about the speed, you can change here to another value. Let's make it much slower. And then you can start having a much slower view of the video. Once you're happy with the movement and what's displayed on the screen, so if you can very likely remove the camera and remove the type point in the display. Once you're happy with what you see on the screen, you can specify a file and render to this file, and this will create an MP4 or AVI file that you can directly upload to YouTube, for example, to share. So in the questions of the users, I'm getting, are the points removed permanently? So no, the points are mostly hidden when you are processing. When you are removing the points, you can always recover them. So let's say this is my truck. You can always recover them by clicking restore removed points. And there is the truck back on the pile. If you want to have a LES file that doesn't contain the point that I just removed, then you go on the point cloud, densified point cloud, after removing the points, and you export the point cloud. When you export, it will export what's visible on the screen. So the ones that are hidden will not be exported. And this way you can generate a point cloud file without these points. As another question, I'm getting, when calculating volume, does the calculation use the bottom point for the surface, or which points are used? So this is very well described in an article in our knowledge base, but just as a quick reference, for the volume computation, you have multiple values there. Some are above the surface that you defined, and some are below, and then it's the total of the volume. So you have everything there. When the points are removed, does this not disturb the elevation model created? Yes, it indeed has a big influence. So when you remove points, it will not, and you start again the processing of the third step, the elevation model will not take into account these points. So when creating the elevation will not pass through these points. So removing, if I look at the elevation model after removing the truck, you will see the elevation model without the truck. If I reprocess the mosaic, the elevation model towards the mosaic after removing the points. Okay, so this is a good overview of the functionality of the rayCloud. Now I'll quickly go over the functionality of the mosaic editor. So the mosaic editor brings this view where you can see a preview of the orthomosaic with a bunch of cells, a bunch of segments there. Each cell is actually a projection of an original image onto the screen. And on the right, you can see each of the original images which have been auto-rectified and that the software placed there on the screen. By selecting the right image, you can make sure that you don't select an image which was, for example, here. You can clearly see that there was saturation on the sensor. So by selecting another image, you're able to make sure that you have the content that you want. Another way to interact with that is you can move the boundary between the different cells. And by moving the boundary in this image as the cars were moving on the road, in this image the road was not there. However, in this other cell the car was there. So you can either select the image that doesn't contain the road, or you can also move the cells to make sure that you cover this area with an area which doesn't have this car on it. You can also change locally the projection type for this area. So there's a whole webinar which is dedicated about this, how to do and what are the influences. But as a quick tip, if you have borders of the mosaic, because the 3D model was not computed well enough, the image will be very, very distorted by trying to auto-rectify it. So this is, for example, a good candidate where you can choose a planar projection. By using planar projection, you are not accurate anymore. So you are not rectifying for perspective, so everything which is above the ground will potentially have a wrong measurement. In that case, it's not very bad because it's just to make it a good-looking image. But you have to be aware that when you use this option, it will look much better. There will be no distortion. However, the measurements that you do there, if you try to measure the roof, it will not be exactly at the right size. If you wanted for this specific project to correct, to have the perfect rendering of this truck and to be able to perfectly measure in it without all these artifacts, you would go in the rayCloud, you would go on the truck which is right there. As you can see also it was moving between the images, so it makes things even more complicated. And you would create a surface that is right on the top of this truck. By creating the surface on top of this truck, you will help the geometry, the software, to know what is the exact geometry of this truck. And by knowing the right geometry, once you reprocess the orthomosaic, you will see that it will be perfectly fitting without any artifacts in the orthomosaic. Another possibility to use this mosaic editor for is that you can, for each of the cell, you can change and adjust the brightness. So if you have an extremely dark image in the middle, which is really messing up with the whole color calibration of the whole mosaic, there you have a tool where you can really either switch image to have an image which doesn't have this issue, or you can adjust the brightness of that specific image. Then the last tool, but I'm going to go only very quickly over it, is the index calculator. This index calculator is mostly useful when you're doing either thermal imagery or when you're doing agriculture and you compute, for instance, NDVI from a modified camera or from a specific multispectral or hyperspectral sensor. this is not exactly the same as an orthomosaic, as it's computed differently to make sure that the radiometry of each of the pixels is kept as accurate as possible to be able to compute indices from that, and indices are very often related to, the most popular indices are really related to health of plants, and you need really to keep the value accurate to make sure that you get the real status health of the plant. So I'm not going to go too much into details about the different options that you can use in the index calculator. And for that, there's also how-to manuals as well as dedicated webinars on how to use this tool. So finally, I'm just going to go quickly over a few additional outputs that can be generated from the software to have a full understanding of what's other capabilities. One of them is the possibility to generate undistorted images. So what's an undistorted image? When you take an image, the software has, the camera has usually a lens, and the lens is very often making the edges of the image slightly curved. This is very, very prominent if you look at an image like from a GoPro camera with a very fisheye lens. If you click on Process, Save Undistorted Images, it will generate a whole list of files in image, which are the original images without this lens distortion. So you see that every edges will be perfectly straight. It is also possible to generate a low-res DSM in Mosaic directly from the initial start of the processing without doing the densification and DSM. This is available when you check this low-resolution Mosaic option. There is a possibility also to generate directly classifying the point clouds. So classifying the point clouds is when you want to generate DTM and DSM. By default, the software is going to use all the points to generate a surface model. So the surface model is going to be the DSM. If you want the software to remove the houses and only to try to make a model of the bare earth terrain, then what you need to do is to there's this option which is called Compute Point Cloud Classification. Once you press on it, the software is going to try to compute automatically what is bare earth and what is objects, such as houses and trees. And it will remove the houses and the trees, and once you regenerate the elevation model, it's going to give you an elevation model to create an elevation model that doesn't contain the bare earth, that only contains the bare earth. For example, if you have this point cloud, that would be the point cloud without everything that is considered as being an object, such as a tree or house. And this would be the point cloud with only the object which is considered as automatically tree or house by the software. And when generating the DSM out of this ground point cloud, you will obtain an elevation model that's that will be without containing any of this objects on it. In the other possible outputs that can be generated in software are the in the orthomosaic, you have the Google tiles, which is an HTML file that contains the email that can be displayed and using overlay it on top of either Google Earth or Google Maps. We also generate MB tiles, which is the format for the very popular service to share maps online, which is Mapbox. In the options, it's also possible to generate contour lines, and you can specify what are the specific parameters to generate these contour lines within this this box. As an example of contour lines, this would be contour lines when you generate them before the point cloud classification, and that would be the contour lines generated after the point cloud classification. So you can see that most of the houses and the trees have disappeared. Another possible output which is generated in this list is the 3D PDF. So we generate a PDF that contains a low resolution version of the point cloud, as well as a low resolution version of the DSM and of the mosaic. This is an easy way, an efficient way to share dataset results with clients, for instance. There's also the possibility to generate 3D models, 3D meshed models, using this generate 3D triangle mesh point. And this will have also a huge amount of improvements in the next version that's going to be released by the end of the year. So stay tuned for more improvement on that. All right. So I've been discussing on many different possibilities and overviews of the software, and this is just really a quick overview, well, quite a long overview of everything that it's possible to do in the software. And what I'd like to underline is that for most of the topics which have been discussed, there is some specific, very detailed articles in our knowledge base which are detailing much more in detail how to do every single step. So for example, if you would go here, you would go in how to, and in this how to, you can, for example, have one which is how to include GCP in the project, and this one will guide you exactly through every single steps where you need to click and how you can really get the different steps into really inserting these GCPs. I'd like also to advertise the other webinars that we have on our website, which I really recommend to watch for specific topics, and also to have a full understanding of why are these GCP important or not. All right, with that, I'd like to conclude this this webinar. I hope that you could learn new features that maybe you didn't know that were existing in Pix4Dmapper and new possibilities. And I'd like to thank you all for listening this webinar, and I hope that to see you for the next webinar that we haven't prepared yet, but which will be available in a few days for registering on our website. And just to make to make sure that everybody knows, this whole webinar will be available on our website together with the other one, together with all the links to all the articles and webinars that I have mentioned. So again, thank you very much for listening to this webinar, and have a very great day, and goodbye.